Hi viewers, welcome to Sevivali Kalvi channel. So today we are going to see about the half adder designing by using PSpice simulation tool. So first of all we have to go for PSpice design manager. So from this program we can select this option. The software will appear here. So PSpice design manager. So first you have to create the workspace. So file, new workspace. So already I have created a lot of project. Now I can select project underscore 7. So the location in this particular drive, every the projects are stored. So project 7 is my workspace name. This is appear in this workspace area. So apart from this, we go for tool and select the schematic. So in the schematic window only, we can able to draw the circuit whatever you want to simulate. So now we are going to design the half adder. So for half adder concept we know very well we need two inputs A and B, and it make four possible combinations of input sequences 0 0 0 1 1 0 and 1 1, and it has a two output sum and carry. So depends on the 0 0 0 1 1 0 and 1 1 combination of input sequence, the sum and carry result will produce in the truth table. Now the concept is present in the truth table. From this truth table we can able to make a k-map, and after k-map simplification we found the result. So that result is sum expression is a xr b and the carry expression is a into b. Now we are going to draw the logic diagram for this half adder circuit using this PSpice schematic, and we can give input and we will show the output with the help of simulation manner. So now we can take the place different parts, that is our AND gate and 7486 XOR gate. So for first sum is equal to A XOR B concept, we have to take XOR gate. That gate can be taken and placed in this schematic area. Apart from this, we can take 7408 AND gate also. Place this 7408 AND gate and place in this schematic area. So again you have to choose digisim. So digisimulation is the one kind of input. So here we can give 0 and 1 possible combinations for both two input sequences, or for both two logic gates, and at last we can take if underscore out. So it is a function which is used for storing our result. So this is the components what we have required for this half adder designing process. Now we just close this window and we can go for a wire. So take this wire. So first input is connected with this pin number 1 of XOR gate, and again the pin number 1 of AND gate is connected with the first input. Carefully you have to connect these wires. If any one line is missing or overlapping with each other, the netlist error will be appeared. So at the time we can't able to produce the proper result. So the second input of digistimulate is taken, and it is given to the second pin of this XOR gate, and also it is connected with second input of AND gate also. Now our input connections are over. Now we have to connect this output of this both two logic gates from output terminals. Okay, so now the connection part also okay and over. Now you just save it. So already I saved two schematics, so I can replace the name schematic 3 and save here. So after that, I can rename it. So now DSTM, stimulate, digital stimulation 1 can be replaced by capital A. That is my first input. And now it is DSTM2 can be replaced by capital B. It is my second input. So A and B are two inputs. Similarly, sum is my output, one of the output. So I can rename it by sum here. And similarly, double click this output variable and make it as a variable name carry. Now this part fixing the input variable and output variable is over. Next we can choose the voltage marker for both the input side and the output side, because you are going to give input 0 or input 1. It will produce the output 0 or output 1, depends on the concept. So now the connection part is over. Now we have to set the stimulus time period. So now the attribute of this A is appear here. I can choose period and on time. So period I just take 4 millisecond, and on time will be 1 millisecond. That means the total time period of my first input sequence is 4 millisecond, and on time 2 millisecond, off time 2 millisecond. So automatically the one period of signal is splitted into 2 millisecond and 2 millisecond. So total is 4 millisecond. Next again I move to second input sequence and click it here. So here the name B attribute is visible in this window, and choose period and on time. Here also I can take 2 millisecond is the total period for the full cycle, and 1 millisecond is on time, and the remaining 1 millisecond will be off time. So according to the setting of this time period, the two input sequences are represented in this graphical manner, on time and off time for the corresponding millisecond time duration. So after that, we just go for this setup. So in this setup, transient should be selected. So here I take 1 millisecond is a print area, and 6 millisecond is my total number of clock period should be appeared in the output. So now this also over. Now you can simulate your program. Now the simulation process is over, and this simulation window you will get a result. So first input is equal to 0, A value is equal to 0, the logic 0 is there, B value is 0, logic 0, and our sum value is equal to 0, carry is also 0. And next A is equal to 0, B is 1. Now the sum result appear as a logic 1 in graphical manner, and again the carry becomes 0. And for the third case, input value goes to 1, A input is equal to 1, B is equal to 0. At the time sum 1, carry 0. And last sequence A1, B1, so sum 0, carry 1. So this is the waveform representation for the given input sequence for half adder circuit. So whenever we want to write a program, we can able to write a Verilog program or VHDL program or Python program, etc. So in this case, if you are using Verilog or VHDL with the help of model sim or Xilinx, similarly we can view the graphical representation of output. At the same time, in this case, we not able to write a program. So because whenever you take a PSpice simulation, so in this case we directly take a circuit, whatever you want to draw. So the particular logic gates are taken, and what are the inputs essential to give, that can be given, and we can produce the output with the help of this logic function. With the help of logic diagram, we can get the simulation output in PSpice simulation tool. In case instead of this PSpice simulation tool, if you use a Verilog coding program, at the time the model sim or Xilinx can be taken as a software. So in that, we no need to draw this diagram, but we have to write a program. So Verilog program or VHDL program. After that, we can run the program. Finally, we will get a same graphical representation output. So whenever you do some experiments in laboratory, we can differentiate in what kind of manner we can verify this concept. If you connect all the components in breadboard connection and you give input, you will produce some output. The same concept can be done with the help of this lot of simulation tool. Directly write a program and simulate it, you will get a output as a graph manner. Similarly, instead of programming, if some person can able to design the circuit in this area like PSpice, etc., which help to develop their knowledge in this domain also. So I hope everyone enjoy this video, and finally you got the result. Whatever you want to get depends on the given input. So everything appear in this graphical window. So students, all of you try to understand all the concept. What are the difference between a descriptive connection in laboratory and simulation tools used to show the output, both the logical diagram representation and the programming representation. So differentiate these all kind of available of experimental setup, and improve your knowledge. Thank you once again. Like my channel and subscribe my channel. And if you have any doubt regarding this experiment, you can ask me at any time. Thank you all. Thank you, viewers.